All right, ladies and gentlemen, today we're going to be awesome together. We're going to start lesson 1.3, and this is all about solving equations with variables on both sides. So the I can statement would be, I can solve equations with variables on both sides. That's amazing. I'm going to try and give you some hints, some tips, some tricks to try and make it as easy as possible for you. But you might also notice the problems that we're going to be doing today are actually directly from your assignment. So that means when you actually copy this down, make sure it gets in your notes so that you can practice it, review it before the actual test and further lessons later on. But when you get to the actual assignment, you can just go ahead and put whatever problem you're wanting to do, C notes, which means we've already done the problem together. There's no purpose in recopying down the problem again. So for example, a nice basic one for us to get started with is problem 2. So again, when you're on the assignment on Google Classroom, whether you print it out, doing it on Kami or paper pencil, you can just write C notes for number 2. All right, so what I'd like you to notice is that we do have variables on both sides, 2x and 4x. Now the easiest way to try and explain this for my students is kind of connected to your everyday life occurrence. Now right now it may not be as much, depends on if your parents allow you to go to the grocery store, but they should definitely allow you to bring in the actual groceries. So especially the 8th grade boys, they are always taking the lazy way. Right, gentlemen? Meaning they bring in the bread, the eggs, the really light stuff, because it's technically the easiest to do. Some of you may be required to bring in everything. Some students naturally take the bigger, heavier items, but whatever the case is, most teenagers choose the easiest route. And that's the same thing for this one here. We've got a 2x and a 4x. So the question is, what would be easier to move? Now, since they have the same variables, technically it's the exact same item that you have to move, but most of you may realize, well, it's easier to move 2 of the same item than 4 of the same item. And as silly as it sounds, that's what we're going to use to help us solve our equation. So it's always easier to move the 2x than the 4x. The smaller the number, easier it is. So I'm going to go ahead and practice that skill. I'm just going to go ahead and let's change it to blue. Subtract 2x from both sides. Because remember, whatever you do on the left side of the equation, you also need to do on the right side. Notice where I placed it directly below the variables. So in other words, on the left side, it disappears. So I have a negative 5 is equal to a 4x subtract a 2x is a 2x. And then I've got to subtract 1. Now, just like the hint that I gave you previously, if you don't like the way this looks, you can just bring the negative 5 over here on the right and then lightly cross that off. So now you have a 2-step equation that we've done a lot of practice on in 7th grade, 8th grade. You're going to use it so much in high school. We want you to make sure you have it down really well. So I'm going to add 1 to both sides. I'm going to be very careful with my integers here. Again, this is a common mistake for 8th graders, especially who go a little bit too fast. Different signs means to subtract, which gives me a 4. Take the sign from the greatest absolute value, so that's why I got a negative 4. I'm going to go ahead and divide by 2 to finish off my solving of my equation. X is equal to negative 2. Now when you're ready for the check, again on this assignment we give you a nice little space there to check it. You're going to go ahead and substitute your value for each location for the x. So in other words, it says 2x, so it's going to be 2 times your x value, which of course is, we think, negative 2. Then I continue on. It says subtract 5 is equal to 4x, or 4 times the x value, which is the negative 2, and of course the subtract 1. So just like order of operations, I'm going to go ahead and work on both sides of the equation and see if they become the same value. Remember, this is what we were talking about last week when we were checking our equations. Now on a 1-step, even a 2-step, depends on if you really need to do that. But once we get to our multi-step equations, it can be very, very helpful. So 2 multiplied by negative 2 is negative 4, and then I got to subtract 5. So I could change this to really adding negative 5, which means it's a 9 with a negative sign, so negative 9. On the right side, I have 4 multiplied by negative 2, which is negative 8, subtract a 1. Or I can do adding the opposite, which means add them up, same sign. So there we go. Negative 9 is definitely equal to negative 9. So therefore, my value of x equals negative 2 is a true solution to this equation. Remember, if you were doing your work and you ended up getting like negative 9 equals positive 9 or negative 9 equals 3, obviously that does not work. So it means either you made a mistake on the check or you made a mistake on the actual solving. All right, let's try a few more. And then again, you'll get started on your assignment. This one here, I need to clean up, which means on the left side, I need to simplify. So I'm going to go ahead and combine my like terms. I can write it as a negative 1x for my work, never for an answer like that. And 5 subtract 2 is a 3. On the right side, I'm going to combine my like terms. Remember, I'm not crossing the equal sign when I'm combining like terms. So I have 4x plus 8. Now I need to make that choice, just like we talked about previously. Which variable do I want to move? Same letter, different value, a negative 1x or a 4x. But again, I'm going to take the smallest one, and I'm going to go ahead and move that. So I'm going to add 1x to both sides. So this gives me a negative 3 is equal to a 5x plus 8. I don't like the negative 3's location, so I'm going to move it over here. Just a little bit easier for me and many students like me. All right, we're going to subtract 8. This is going to give me a 5x is equal to, and I am just double checking to make sure I didn't make a mistake. And it looks like I did. Did I write down the problem? Ah, that's why. Okay, here we go. That's supposed to be a plus 3. Phew. There we go. Okay, so again, be very careful with those signs, because like you just noticed, I was going to make a mistake. Let's be careful. Divide by 5. There we go. That looks a lot better. Fractional answers are still valid answers, though. All right, so on the check, remember it says 5 subtract, but my x is a negative 1. And then a subtract 2 is equal to a 3 plus 4 times the x value, and then a plus 5. And x we think is negative 1. All right, on the left side, adding the opposite really gives me a 5 plus 1 subtract 2. 6 subtract 2 is a 4. I think I should get a 4 also on the right side. Let's see here. 3 subtract a 4 plus a 5. 5 plus 3 is 8. Subtract 4 is a 4. There we go. Now, if I had a mistake on my work and had that fraction answer like I was unfortunately going to get, because I wasn't careful with the signs, when I went to check it, it would not work. Not because it's a fraction, but just because it wasn't going to give me the correct answer. Again, the correct answer is negative 1. All right, on this one, if you notice, the left side, I don't have to combine any like terms. Makes it a little bit easier. The right side, I just need to use my distributive property, so let's do that. I've got an 8m and a subtract 10. Why did I put x? Because x is awesome. There we go. Subtract 10, or negative 10. On the left side, I've got a 3m, subtract 10. Now, I want to remind you, you're always going to start with the variable. So I'm not going to start with the tens, because some of you may be noticing something. So, same idea. Let's move the smaller variable. So subtract 3m. And you're not always going to subtract. You might have to add. You just need to move the smaller variable. This is going to give me a 5m, subtract a 10, and over here, a subtract 10, or negative 10. But wait a minute, I don't like it again, so I'm going to move it over here. All right, this looks like a better problem. Add 10 to both sides. And you may be saying, wait a minute, Mr. Murillo, this is going to give me a 0. That is allowed. You can have 0 there. 0 is a valid number. Because when I divide it by 5, if I have 0 cookies for 5 people, there are 0 cookies. And maybe 0 friends too, because they love cookies, right? So make sure you actually are careful with that 0, because a lot of the time students get confused on how to set it up, and somehow they get a magical 1 for their answer. So I think my answer is 0. Let's come up here on the checkbox and see if I'm correct. So I've got 3 times the m value, subtract 10, and we think m is 0, is equal to 2 times 4 times the m value, subtract 5. All right, so on the left side, 3 times 0 is just 0, and 0 subtract 10 is obviously negative 10. On the right side here, 4 times 0. Some students may just say, well, Mr. Murillo, I know 4 times 0 is just 0, so can't I lightly cross that off? Ooh, genius. So it's really just 2 multiplied by negative 5, which is negative 10. So technically, you could have crossed that one off a little bit if you wanted to as well. Negative 10 equals negative 10. Excellent. Our answer is good to go. Again, just a few more. Ooh, fractions. Some of you are like, I don't like fractions. It's okay. Same strategy again. Which is smaller variable? Even though it's fraction form, we should automatically know that a negative is smaller than a positive. So I'm not going to always say move the one that's on the left. I always keep going back to move the smallest variable, because sometimes the smaller variable will be on the right side, and then you got to move it to the left side. So if I add 2/5 p to both sides, line up my equal signs, I have it as 3/5 p plus 11, and that's equal to 2. So if it's equal to 2, I'm just going to put the 2 over here. All right, got a nice 2-step problem now. Subtract 11 gives me a 3/5 p is equal to negative 9. Because again, different signs, subtract, take the sign of the greater absolute value. All right, from here, it looks like just the other day. Let's go ahead and multiply by the reciprocal, both sides. The reciprocal of 3/5 is 5/3. And if you notice, we are able to cross cancel. So this would give me p is equal to a negative answer, because a negative multiplied by a positive is a negative. So let's cross cancel. 3 is 1, 9's a 3. So I think it's going to give me negative 15. So even though we provide you the answers, again, the check is a strategy to see if the answer really makes sense. And we're going to be using that a lot when we get to chapter 4. All right, so when you check it again, it's going to look like this. Negative 2/5 multiplied by the p value plus 2. And the value of p we think is negative 15. So I'm just going to write it as negative 15 over 1 so I can practice cross canceling. On the right side, it is 1/5 times the value of p plus 11. And again, we think p is negative 15 over 1. All right, let me zoom in. All right, so plus 2 stays the same. Cross cancel. 1 and 2, nope. But I do know it's positive, right? Negative multiplied by negative positive. So right here, 1 and 3. So that's going to give me a 6 plus 2, 8. So I'm hoping the right side also comes out to an 8. Over here, positive times negative is negative. 5 becomes a 1, 15 becomes a 3. So it's negative 3 plus 11. Different signs means subtract. Take the sign from the greatest absolute value, which is positive. 8 equals 8. Excellent, which means my answer for p equal negative 15 was accurate. All right, so we got 11. Ooh, and some word problems too. Nice. All right, the reason I selected number 11 is because a lot of students, for whatever reason, forget about this little 1 here. If they remember the 1, sometimes they say, oh, 5 subtract 1 is a 4, but we can't do that. Again, that is not correct order of operations. So I could bring down the 5 and multiply. Negative 1 times n is negative 1n. Remember, that's allowed for work. Negative 1 times negative 4 is positive 4. On the right side, if I want to, I can continue my distributive property. 3 times n is 3n. 3 times 2 is 6. On the left side, I need to combine my like terms. I'm double checking my signs. -1n, +4. Looks good. So I'm going to circle those. So that gives me a -1n plus 9 is equal to a 3n plus 6. Now again, back to the silly grocery example. Take in the smallest amount, or lightest amount if you like that description, which is the -1n. So that gives me 9 is equal to 3n plus 1n is 4n. And then we got a plus 6. If you'd like to, you can go ahead and bring that over where it's equal to 9. So subtract 6 both sides. 4n is equal to 3. Oh, looks like we're going to get a fraction answer. Now don't freak out. Just because it's a fraction answer doesn't mean you did something wrong. It just means the check is going to be a little bit more complicated. All right, so it looks good. Let's check now. So remember on the check, it is 5 subtract the quantity, parentheses, fraction, 3/4, subtract 4. Oh, I wanted to change the color with our substitution. So that is blue here. So 3/4. Because that's the value of n, subtract 4. Come on. There we go. Is equal to 3 times the quantity. Got to write my fraction. 3/4 plus 2. And remember, the checking here is really just a continuation of what we did last week. We're talking about, actually, first week of school, where we're talking about adding and subtracting fractions. So this is really 5 subtract something is equal to 3 multiplied by something. And they should come out to the exact same. So I'm actually going to go to the right side, because if you notice, I could actually add those, and it's really just going to be 2 and 3/4. If you'd like to, you can go ahead and write it as a improper fraction. 4 times 2 is 8. Plus 3 is 11, so that's 11/4. And then if I multiply, I get positive 33/4. Now over here, can't really do that as well, but some of you may be thinking, well, this is like 75 cents. So it's going to be negative. And if you think about 75 cents, that's really $3.25 when you subtract it. So that's really 3 1/4, which would really give me 5 plus, because negative times negative is positive, 3 1/4. But I can add those up, which would give me 8 1/4. Let's see, 4 times 8 is 32, plus 1 is 33. Oh, very nice. So even though it gave me some weird fraction answer, I was able to substitute and check it and practice my skills with fractions like we practiced the first week of school, and it looks good. All right, let's see here. Again, we're concentrating with variables on both sides, so when I write this word problem, I think I might have 2 companies. So if you notice, it says Rapid Rental Car Company charges a $40 rental fee, $15 for gas, and 25 cents per mile. So we're going to put the first company as $40 plus $15 plus 25 cents per mile. And if you'd like to, you can put M for mile or just X as the generic. For the same car, the other company, Capital Cars, charges $45 for rental and gas. So if you notice, it's combined. So that's $45. Plus, this time it's 35 cents per mile. So they're, you know what, 40 plus 15, can I just change that real quick so we can compare it into the 55? Because that's what 40 plus 15 is, right? So if you notice, the first company charges more initially, but it's less per mile, where the second company charges less initially, but more per mile. So it says, according to part A, find the number of miles for which the companies will charge the same. Then find that charge. So essentially, we're trying to solve what m is equal to. That's the number of miles. So let's talk about our variables again. We want to move the smallest variable. So I'm going to go ahead and subtract 25 cents per mile from both sides. Which is going to give me 55 is equal to 45 plus 10 cents per mile. I don't like the 55 there. Let me bring it over. Sorry, I forgot to write subtract. So I've got 10 cents per mile is equal to 10, and I'm going to divide, and you could probably just bring this up on your calculator really quick to find out how many miles that is. So let's see here. Let me grab my trusted calculator. My calculator, so really my phone. Come on, calculator. There it is. All right, so I'm going to type in 10 divided by 0.10, and that's going to give me 100 miles. So it means at the 100-mile mark, both companies would be charging the exact same. So it says find that charge. So I can take a look at either side here, whether it's company Rapid Rental or Capital Cars. So if I'd like to, I can just say, okay, it's going to be $45 plus 35 cents per mile. And it's 100 miles, right? Do you know the trick? You can just move your decimals. So it's really just 45 plus 35. So each company will charge, if you add that up, charge is equal to $80. 45 plus 35, $80. So company A, company B, same thing. The next part says, though, the Barr family estimates that they will drive about 95 miles during their vacation to Hershey, Pennsylvania. Which company should they rent their car from? Now, we already know that 95 miles is pretty close to 100 miles, which means their charge is pretty close to $80. But since they're not doing the full amount of miles, we're really just trying to save them a little bit of money. So the first Rapid Rental, so I'm going to put RR. Their scenario was 40 plus 15, which was $55 for the initial charge and gas, plus 25 cents per mile. And the mile says about 95. Can't even write today. Then the other one was Capital Cars, and that was an additional that initial $45 plus 35 cents per mile. And it's about 95. So same thing on your calculator. You're just going to go ahead and multiply by the decimal. So I'm going to type in 95 miles times 0.25. That's a quarter, right? So that's 23.75 that I'm going to add to the $55. So I just keep it on my calculator, press plus 55, and I got 78.75. All right, over here on Capital Cars, on my calculator again, I'm going to do 95 times, but this time it's 0.35. So that's $33.25. And their initial charge was 45. So on my calculator, I'm going to press plus 45, and that's going to be $78.25. So really, does it make that much of a difference right now? No, not really, but eventually it might get into a really big mile trip where it can cost a lot of money difference. So you really got to figure out which one's cheaper dependent upon the scenario. So obviously, based off this, if they want to save 75 cents, they would go with the Capital Cars. So go ahead and put a quick sentence here. Let me actually type it in. The Barr family. Whoa, where'd it go? So I got a funky typing there. Can save 75 cents by renting from Capital Cars. Something simple like that. Come on. There we go. The Barr family can save 50 cents by renting from Capital Cars. Again, not much, but that's okay. But the whole point, again, was being able to compare scenario 1 to scenario 2, or company A to company B, whatever the case may be. All right, and if you followed with me on this whole video, I will tell you something about number 16 on Google Classroom. So make sure you read those instructions, please. All right, be awesome. Continue on working, please.